Hello. In this short presentation, I will demonstrate how to start with the rocket science workshop exercise. In this assignment, you will be in charge of a rocket flying between Earth and Moon. You will need to implement the gravitational fields of both astronomical objects, the rocket's throttle and thrust, burning fuel, long story short, the rocket science. To start with, you first of all have to download the project from your GFC and project folder, which can be accessed either by the link available here in the web page of the exercise, or also from the main page, the home page of the module. It's down here, project folders. Okay, I will use this link. Yes, I'm a part of Kingston University, and in a few clicks we will see all available GFC projects. We have to choose this one, the rocket exercise. Okay, and whilst I'm hovering over this position in the list, I can access more options and download the project. It will take a couple of seconds, and I can save it on the desktop. It's perfectly fine. The file is here, and this is what is inside of this file. So clicking at this folder, I can ensure that I have all the project files inside. The important point, of course, is not to start Visual Studio from here, because it's a zip file. So Visual Studio will not know what to do with that. I will go over for one level up, and basically this is my project folder. I need to move it to wherever I keep my other GFC folders, GFC projects. So that's my folder. I have a GFC library here, other GFC projects like Roll and Fall, which we did not long ago, and I will just copy and paste my project folder here. It's important to double check that the project folder is located side by side with the GFC folder, library folder, and under a single click I can find the SLN, the solution file. If it doesn't look like this in your computer, just double check if relational position of GFC and the project files are not accurate. Visual Studio will just not will be unable to find all necessary files. So now I can load the project to Visual Studio. Okay, you should only open project from a trustworthy source. I trust myself, so I can click OK. And in a moment I have my projects loaded in Visual Studio. The first thing I will do is a quick build and run, just to check if everything is working fine. Yeah, it takes a couple of seconds. My game rocket nearly done. Yes, so that's my project. It does absolutely nothing apart from that I can change the direction of the rocket, because this is the starting point of this project and you are supposed to finish this project. So this was the starting point. I will now guide you through the main features of the source code of this project. So first of all, let's have a look into the main my game file. Main CPP is not particularly interesting, but this is the my game CPP. First of all, you can see that we have three sprites created here. One is the Earth, the other is the Moon, and the most important, the most interesting is the rocket. The Earth and the Moon are just decorations. They are not moving anywhere, so they won't even be updated. One of the most important functions in GFC is the onUpdate function, and this onUpdate function is surprisingly short. We call the update of the rocket, and then there is just a simple test with specialized functions. If the rocket is landed on Earth or the rocket is landed on Moon, and then if the rocket is crashed, then the game is over. So the game is over if the rocket is landed on Earth or landed on the Moon, and at the same time it's crashed. So it's basically the test for the game over. Another important function might be this one on draw. Here we have a short code snippet that creates stars. These stars are quite nice, nicely shining in this program, but this is not essential part of the code, so I will not analyze it in particular. When we draw all the sprites, the Earth, the Moon, the rocket, the rest of this code is mostly displaying various text messages. You can analyze this code in your spare time. For now, it's not so much important. On initialize, we'll create stars in random positions and load images to the rocket and animations to the rocket. We have some kind of initialization of the position and rotation for the rocket. Game over will change the image of the rocket into fire, so it will look like exploding. And one other aspect of this game is on key down, the left key and the right key will subtract or decrease or increase the thrust. So one thing that you can notice in this mygame CPP file is that the actual logic of this game is not here, it's somewhere else. The point is that this game is using a separate class created specifically for this game, the class of rockets. This class is shown here. I will start from the header file. Header file is where the rocket class is defined. So I will go to the document rocket.h. This is a class rocket inheriting after the C sprite. So rockets are in fact a specialized class of sprites. This class knows, or objects of this class, instances of this class, have a memory over fuel, over thrust, and over landing speed. So these are the three things that this class can store. And we have a number of specialized functions here. Not a very long list, but quite useful list. So, apart from two constructors and destructor, which are used to construct new rockets and destruct rockets when they are not anymore needed, we have a getFuel function, which will return the current value of fuel. You can see some additional logic here. If by any case the value of fuel drops below 0, so becomes negative, then this function will return 0, and if it is any positive number, it will just return the fuel value. We can also set the fuel directly. This fuel means this expression refers to the member variable, this variable here, and it is set up with the parameter of this function, so you can set the current value of the fuel. Then we have a similar logic for the thrust, rocket thrust, getThrust. Again, if the thrust is less than 1, the function will return 0, and in any other case it will return the thrust value, whatever it is. And set thrust is also very similar to set fuel. We also have a function called reset, which sets the speed of the rocket to 0, sets the fuel to 100, 100 means full, thrust to 0, so it's then switched off, landing speed is initialized as 0. Additional status information function is landed on Earth. It will be landed on Earth if the x-coordinate is less or equal than 125. What it means with 125, that's the position of the rocket right now. It now is at the x-coordinate 125. Anything left to it would mean touching the Earth. Okay, and anything higher than 125 would mean the rocket is above the Earth in the space or on the Moon. And similarly, the coordinate 720 means the rocket touching the surface of the Moon, so actually landed on the Moon. And we also have function is crashed. Is crashed just checks the landing speed. If it is above 100, this means that we have crashed into the surface of either the Moon or the Earth. And another function, one more function, provides the landing speed. There's one more function that is not defined in this file, and this is the onUpdate function. OnUpdate function is the function that is directly called from within the My Game onUpdate right here when we call the mRocket. Okay, eventually it will calling this function. It's this function onUpdate. And the onUpdate function, its entire definition is located in the rocket.cpp file right here. This file has definitions of constructors and destructors, and then definition of the onUpdate function. This onUpdate function is actually where all the logic of your game is located. This is also where you are supposed to insert your code. So our canvas instruction, which is here, lists a number of steps, 10 steps to succeed. Alright, 10 steps to succeed are reflected here in these comments. Step number 1, step number 2, step number 3, 4, 5, 6, 7, up to 10. At the end of this function, you can see that we have some code already created. OnUpdate, this is calling the rocket, the original sprite update function. Then setting the rotation. Setting the rotation means actually that when the thrust is negative, or the movement of the rocket, even if it is standing, when the thrust, it can rotate left or right depending on the direction. So it will be pointing right when it is traveling from the Earth to the Moon, or pointing left if it is traveling from the Moon to the Earth. So that's this logic. It's done for you. You don't have to do anything about it. And here is the landing code. The landing code will check for the, first of all, it will set up the landing speed, so it will register the speed at the moment of the landing. Something that is very important in order to later find out whether we had crashed on the surface of the planet or not. You can read this code later on, perhaps. Now let's go to the top of this onUpdate function and try to start solving the exercise. Step 1, burn your fuel. Burn your fuel. Decrease the fuel level depending on the absolute value of the throttle. This step is already done in your workshop program. Indeed, it is. It is right here. And this step sets the fuel to the value equal to the current value or the previous value of the fuel, which is provided by the getFuel function, minus the absolute value of thrust divided by 20. If we forgotten to divide thrust by 20, we would have fuel burning out very, very quickly, too quickly, impossible to fly anywhere. So it has to be, this division is absolutely necessary. The second step is to calculate the mass of the rocket. Calculate the mass of the rocket as the total of the own mass of the rocket and the fuel. Okay, the total mass, own mass of the rocket and the fuel. You may want to store this value in a variable of type float. Okay, so let's have a look into the code. It suggests here it should be the rocket own mass, for example 120, plus the fuel. So uncomment the next line of the code and type in the formula. Alright, let's uncode this. What it is a definition of a variable, of a float variable mass. Okay, so it follows the suggestion here. You may want to store this value in a variable of type float. So this instruction is also started for you already, and I will finish it now. Okay, so if the mass should be the rocket own mass and the fuel, you can use the canvas page to find additional information necessary to solve this puzzle. So useful functions: get fuel, retrieve the amount of fuel. This is exactly what we need. Okay, get fuel is one thing that we need, and also we have some game engine values, and here we have the rocket own mass 120. Okay, 120 is the rocket own mass, empty mass, not counting the fuel. So everything that we need to do now is to take 120 as the rocket own mass and add the value of the function get fuel. Okay, and this will be the total mass of the rocket, comprising the rocket own mass and the fuel. So let's do it. Float mass equals 120 plus get fuel. Empty pair of brackets, very important. Even if a function doesn't take any parameters in C++, you still need a pair of brackets. Semicolon to finish the instruction. We've done step 2. Your next step will be step number 3. You also have here an initial definition of a variable. So float r_earth. R_earth will be the distance from the Earth to the rocket. But step 3, as well as all other steps, I'm leaving for you as an exercise. So step 3, calculate the distance from the center of the Earth to the rocket. Step 4, calculate the distance from the center of the Moon to the rocket. Step 5, calculate the Earth and Moon's gravitational force using the famous Newton's formula. F equals gmm over r squared. I will comment on this a little bit, because we have here gm value for the Earth, gm value for the Moon. In this case, gm does not mean General Motors. No. Gm means the gravitational constant multiplied by the mass, the big mass, the mass of the planet, either Earth or the Moon. So this gm is this part of the formula. Gm is already given as 12,000 for the Earth or 3,000 for the Moon. And the rest of this formula, the small m is the rocket mass, which we calculated in step 2, and you have it here. Okay, so it will be this gm, for example 12,000, multiplied by the mass and divided by r squared. R squared is the thing that you calculate in the step 3, and then for the Moon in the step 4, that's the distance from the Earth to the rocket or from the Moon to the rocket. It should be squared, and it should be used to divide the value of gm multiplied by the mass. That's how you can find the force. Then a few remaining steps. 6, you will need engine force. 7, you will need to calculate the net force. Point 8, apply the Newton second law of motion. And step 9, calculate and apply new speed. And step 10, update the object position. These are all explanations I wanted to give you right now. Thank you very much for watching and happy programming. Bye!